Okay. Hello, Shiva. My name is Amit Sanapala. I'm from Hyderabad. I'm currently pursuing my master's degree in computer science. I'm in my second year from IIT Chicago. Uh, that's about it. So can you just tell me a few words about you?
Yeah, myself, Sivakumar, I have 15 years of experience as an Oracle DBA, working in all the critical platforms like banking and financial and retail side.
Mm-hmm.
And I have also have a training experience from last 7 years.
Okay.
So possibly I may give most of the real-time scenarios and case studies.
Okay. Okay. That would be great.
Yeah, and what are you looking for, and do you have any RDBMS background as of now, or?
Let me tell you. Actually, I did my undergrad in electronics and computers, so I didn't have any knowledge about computers back then. But after coming here, I've learned a few things like Oracle thing. I'm good with Oracle basically. That is the SQL thing.
Mm-hmm.
So for now, I'm kind of okay with SQL, and I'm currently pursuing with this thing, advanced database thing. So I think things should be fine. I mean, yeah, things should be fine for me to explain things.
Okay, that's fine. Yeah, as you have already um, little bit experience in Oracle and PL SQL, it will be easy for understanding the Oracle DBA stuff. So
Yeah.
mostly for the Oracle DBA, it's as a prerequisite you should have a knowledge of SQL, how it works, and because
Yeah.
if you don't know the SQL, most of the SQL queries we do in the administration part, and also the PL SQL stuff, how the background Oracle handles internally,
Okay.
it'll be best to know.
Mm-hmm.
So my DBA class would be 5 to 6 weeks and 1 hour of theory, and if it is a demo or any case study, it would be 1.5 hours.
Mm-hmm.
And if you need in urgent, like to be completed in 3 to 4 weeks, even that
No, no,
we
no.
can
I'm good.
do. Yeah. So the most, if that is the case, of the part in the weekends. So if not, let us start into the section. So as this is the demo,
Actually,
I'm going to
okay.
cover
Actually,
the
I will.
Oracle
Yeah.
architecture part.
Okay.
And before we start, the Oracle architecture will closely relate to the operating system, like
Mm-hmm.
how our Windows or Linux operating system works. It will have a memory and the background processes, the task manager, and whatever the services you start, they up and running, and have the service monitor and task monitor. Those are operating system provided utilities. And likewise, the Oracle has all the setup, like it should have the memory, and it also have the process. You also have the monitoring stuff, and as a DBA, you will be knowing all the things like what is the architecture, how the memory will be distributed to the Oracle, and what are the mandatory processes that will be up and running, how to monitor the processes, and we'll be understanding what each process does and what is its importance.
Mm-hmm. I have a small question.
Yep.
What is the difference between Oracle DBA and Oracle Apps DBA?
Yeah, a good question. Oracle Pure DBA, we can call it as a core DBA. It basically deals with the Oracle database.
Mm-hmm.
And Oracle Apps deals with the WebLogic server and Oracle applications.
Mm-hmm.
And it's not the same as Oracle DBA.
Mm-hmm.
And only there are different levels in the Oracle apps. One is functionality and basis, and basis will be is a administration part where You need not know or any Oracle
Okay.
apps
Yes.
related knowledge. Like
Okay.
if there is any like financial side or PeopleSoft, or you have different like 7 to 8 different sectors within the Oracle apps. Like if you are an MBA guy and if you have a business knowledge or financial knowledge, how the banking, the ledger and everything works,
Mm-hmm.
so then you will be eligible to work on the Oracle functionality on the financial side.
Mm-hmm.
Likewise, the payroll stuff and the HR, there are different sections. But talking to the Oracle DBA side stuff, you can fit into the Oracle apps administration side, where you only configure and plug in all the different components within the Oracle apps and provide the support to the Oracle functionality guys.
Mm-hmm.
Yeah, that's the difference.
Okay. Thank you.
Yeah. So Oracle database it's an RDBMS similar to SQL Server and Sybase DB2, and all these RDBMS have some set of rules which are need to be bound or to be called as RDBMS. Unless these RDBMS follows those set of rules, the RDBMS is not it's certified. So the rules, as you know, you might have known the normalization rules, the first
Yeah.
form,
Yeah.
second
Interesting.
form. Yeah. Uh,
Knowledge pattern.
yeah, these all DBMS derived from those normalization factors and applied on the boycott rules. We have 12 boycott rules. Every RDBMS
BCF,
need
right?
to compromise. Yeah, BCF rules. And mostly the Oracle compromises the most. I can say 5 to 7 out of 12, and not 12, any of the RDBMS is still compromising.
Mm-hmm.
Yeah, the architecture here will be like a client and a middle tier. It would be either a web page or any third-party application or any of the online or mobile banking. It will be connecting to the server, and whatever the connectivity is, we call it as Oracle networking layer or Oracle networking, which will be different components we discuss in the networking part, will be useful to connect to the server from any of the client. As a Oracle DBA, we should be configuring and we should be providing the IP addresses. If it is application, it would be have a hard-coded stuff where it should connect to the particular server. Or if it is a SQL plus and you are using your own laptop to connect to the database, you will be configuring those port addresses and host addresses of the particular database server where you want to connect. So this is how the connectivity works, and going further, there will be in-depth configurations of how we configure the networking.
Mm-hmm.
So coming
So
to the
can I ask
database,
something?
yep.
Is there a way can I record this thing so that I can listen to it again?
Yeah, I don't have that flexibility as of now, and if you have, you can go ahead.
Yeah, like, is there an option?
I think it would be like because whatever I'm not sure about the GoToMeeting stuff, but there are some tools.
Okay, I'll just talk to them and make sure I have something so that I can review it.
Amit, sorry, what was
Come
your
again.
doubt?
Hello?
What was your doubt, Amit?
Hi, can I, is there a way can I record this thing so that I can listen to this class again or something?
I'll send you the recording, Amit, don't worry.
Okay, thanks.
Okay.
Okay.
Yeah, here we are, Oracle database architecture stuff.
Mm-hmm.
So the upper rectangle, we call it as an instance, and it's nothing but the memory area where we don't see any physically, but it represents the memory part where it captures or some of the memory from the OS, like how much we dedicate to the database. If we have 8 gig on the operating system side, we can dedicate at least a minimum of the 40% or maximum of the 70 to 80%, because if we allocate more than 85%, the OS may go down lack of the memory, and it may corrupt the database. So there are certain limitations how much you can allocate from the operating system. So this memory is allocated from the operating system, and the area we call it as a SGA. So SGA is a system global area. It's nothing but a memory chunk, and which is allocated purely for Oracle database to maintain it, um, uh, its data related stuff and its processes. Like when you open MS document or Microsoft Word document, if you do anything, even you don't save the document, you can still do a Control Z, and you can revert back whatever the changes you do, right?
Yes,
Do
yes.
you know how it works? Like,
Redo, undo, right?
yeah,
Control Y and
basically,
Control Z.
yeah. Basically, it uses, yeah. Basically, it uses the operating system memory, where initially the data will be stored in the memory, and you can redo and undo. And
So you
if
call it a
you
buffer, right?
really yeah, it's a buffer from the operating system level. If you really observe, if you copy like more than 200 pages without saving the document, so till then whatever the 100 pages document will be only saved in the memory, and you will feel the real difference. The document will be slowed down, and whenever you move the pages, it will be very slow, and sometimes becomes irresponsive, only because of the memory is more occupied, and for that reason the document don't respond as expected. So when you save it, and you feel the performance improvement. So what does that mean? For that particular point of save time, the document got saved to the hard disk, and then after whatever the changes there are minimum and only be in the memory, and the performance will be improved. The
So
same
one more
similarity,
question.
yeah,
So you're calling hard disk and memory, right? The memory as in RAM.
yeah, memory is in RAM.
Okay. Thanks.
Yeah, hard disk is like when you open the document, until you don't save or you name the document, the file's contents will not be saved in the hard disk, right?
Yes, yes.
So till then it will be in the memory. Normally what we do, we tend to type only 3 to 4 pages, and most we deal with the small documents, and we don't feel that difference. And if you deal with the 300 400 pages, and if you don't save the file and keep on writing the document goes irresponsive, only because of the entire content is in the memory, and the memory will become irresponsive if you load more into the memory. So at that point, you need to save the file to release the memory. In the same way, when we talk to the Oracle database, in the SGA, you have 3 components. One is database buffer cache, and read log buffer, and shared pool. These are the 3 main areas. And we talk about the database buffer cache. It will be like whatever the data you insert to the database, you load to the database, or you manipulate, or you read from the database. For example, you do a select star from EMP, the data will be literally pulled from the hard disk and loaded into the memory. Then from the memory, it will be loaded to the push to your screen, like SQL plus window. So the flexibility is here. Why the memory is in picture? Only for the better performance or the fast access. For example, if you do a select for the first time, and if there is no memory in between, every time it has to access the hard disk. That slows down the process.
Yeah.
And when you have the memory in between, it need not directly go to the hard disk for the second time. It directly access the data from the memory itself. Likewise, if you have different users, the database may tend to have more than 1,000 users or more than that accessing the same data. So they all get routed from the memory itself, because the data where they are going to select, it is already in the memory.
Okay.
So likewise, as a DBA, we need to monitor what is the memory utilization, and if we want to increase the memory to increase the performance of the database, we need to increase the memory, or likewise, the DBA role comes here.
Okay.
And the redo log buffer. Redo log buffer, it records whatever the changes you do to the database. Every change will be generating a redo, and that redo stuff will be there in the redo log buffer, and this primarily used for the recovery purpose. For example, while the database is up and running, and due to some operating system level corruption, database goes down or a crash down. While starting up the database, there will be some of the ongoing transactions or uncommitted transactions or incomplete transactions, and all those transactions should be completed. For that process, it will use the read log buffer information and online read log files information to recover the database and to make the point in time. So this is to make the consistency. So for consistency, I can give a real-time example. If you have a bank account and if you have a ATM card and you have an online banking access, and the same time, when you're doing activity from the online banking, you're transferring some amount to the third-party account. In the same way, you have given your ATM card to your family members. At the same moment, without knowingly, they also tend to do ATM withdrawal. So, what if there is no consistency? If you have a 10K account, 10K balance in your bank, you already transferred 5K to the third party, and the same moment your family members trying to pull out 8K from the bank.
Okay.
So if there is no consistency, two transactions gets completed and bank will be in loss, right?
Yes, yes.
So always the consistency, whenever you are doing the transaction for your bank, there will be a lock held until you complete. It won't show the balance to the ATM.
Okay.
So mostly the same parallel transaction for the same account will be very rare situation, right? If you talk about the corporate level, for the corporate level, it may be very frequent situation where you fall into these kind of situations. So Oracle has an internal mechanism which has a read consistency and write consistency to avoid these kind of situations. And wherein as if you take another example, railway reservation or the flight bookings, when you tend to book the ticket, at that time the waiting list would be 9 or 10, and the 9 waiting list will be locked to you until you complete the transaction. Or else at the time when you complete the booking, the waiting list may be 200 or 300 where you are not interested to book the ticket. So that type of consistency is always there in every area. So to have that, there are different processes which complete or which manage this internal consistency. So coming to the shared pool have two parts. One is library cache and one is data dictionary cache. Library cache will be having what are all the recent SQLs that you executed. It will have a plan. For each and every SQL there will be a plan, and it will go according to that plan. The plan is nothing but what is the best way to access the data from the data files, and what is the mechanism that should be used for that SQL. For example, if you do select star from EMP, how fast yeah, no, before it accessing data to the buffer, it will generate a plan how data should be selected. Either it should use index or do a full table scan, all those stuff. So those are all will be impacting the performance of the query execution, or how fast you retrieve the data. So uh, in order to satisfy that, each SQL will be having a plan. That plan will be stored in the library cache, and when you re-execute the same statement, first it will check whether that statement is already executed, and if it is already executed, it will be stored in the library cache, and it will pick the same plan and it will execute, because the same plan is already there, and then it will check whether the data is already in the buffer or not, and if the data is already in the buffer, it will get data from the buffer itself. So sometimes query will be there in the library cache and data will be flushed from the buffer cache, and at that time data will be repulled from the data files. So the plan we can discuss later in the other sessions. And data dictionary cache is all about the information about the data, like how many tables were there, how many users, how many schemas are existing in the database, and whenever you log in to the database and you fire a query, the initial process is to validate, because as a RDBMS, as a Oracle database, the security is also major important. Whenever someone accesses the data, it should follow the security process. For that, it will be validated in the data dictionary cache. It will verify whether you are allowed to access the data, or is that your own data, or you are selecting from any of the other user, or do you have a privilege to access that data. All those validations will be done. Only the validation will be done very fast, because the data is preloaded into the memory. It need not access the data files or the hard disk to verify the data. So it may take long. To avoid that, the data dictionary data will be preloaded into the memory to fasten that process. So these two will be in the shared pool, and you also have some oval shaped yellow background things. They're nothing but the processes we discussed from SMON. SMON is and these are all the mandatory background processes, and apart from that you also have other processes, but they are not mandatory. So SMON is the system monitor. It will be doing the instance recovery, and it will also clean up the temporary segments within the database to free up the memory. And if sometimes instance gets a abort shutdown or abruptly down due to any of the issue, the SMON come into picture and does the recovery from the online redo log files, as we discussed earlier. And the PMON is a process monitor. Like each and every session or each and every time a user connects to the database, a process gets created on the database server, and it will be allocated with some memory. And whenever the user completes or user abnormally terminates session from his laptop or a system or a desktop, the process will be lying active on the server side but doing nothing, occupying some of the memory chunk. So if you have more of those kind of processes, the memory will be fragmented and you see the performance issues on the server side. So in order to avoid those, what the PMON does is it will keep on monitoring all the processes. If any of the processes is idle or it's active but it's not complete with the client, then it will kill those processes or clean those processes and release that memory. So that's a responsibility of the PMON. And RECO is the recovery process. It does do a recovery during the instance startup. So as I said, Desmond will initiate the recovery, but the recovery will be actively done by the recovery process. And most importantly, we have a DB writer, checkpoint, log writer. These are all will be responsible for the data consistency. And DB writer will be pulling the data from the physical data files and writing the information into the buffer and writing back from the buffer to the data files. So a checkpointer is a process which maintains the consistency. Whenever the checkpoint occurs, it will invoke the DB writer to write the data, whatever the manipulated data, whatever the updated data which is in the memory. It will initiate DB writer to write back the data to the database files. And DB writer, what it does, before it writes the data from the buffer, it will invoke log writer saying that, hey log writer, I am going to write my data to the data files, and why don't you write the redo data to the online redo log files. So log writer will be doing from the log buffer to the online redo log files, and DB writer will be writing from the database buffer cache to data files. And there is a line related to redo log as well from the DB writer. It is only to invoke the log writer. So before the DB writer runs, it will invoke the log writer, and only after the log writer completes writing the data to the online redo log files, the DB writer will wait, and then it will write the information from the database buffer cache to the data files. And the checkpointer main role, it will execute for every 3 seconds within the database. So every 3 seconds, its primary responsibility is to make sure the database is in consistent mode. So it will generate a system change number and it will update the control files. And we talk about the control files after we discuss the archiver process. The archiver process is the process, it will archive the online redo log files. Once the archive online redo log files, if you give 5 MB or 1 MB or 10 MB, the max we have is 20 gig for the online redo log files. Once the 20 gig file gets filled, it will archive to some other destination or to the backup location, only for the future usage. In future, if you need to restore or you need to recover the data database, these archive log files will play a major role in recovering that database. So that's about the instance.
Between, what exactly is the difference between archive and the recovery thing, the RECO?
So archiver does, it will not do the recover, but it will archive the online redo log files. That means it will archive the data and keep for future usage. But recover process, it will find that do we have any archive log files for recovery, and if it finds, it does the recover.
Okay.
Yeah. So that's about these instance. And coming to the physical structure, which is nothing but the database. These two are the main components for any database. you will have an instance and a database. Instance is nothing but a memory, and database is nothing but a physical data location, and instance used to manage that. So if you, for each instance, you have only one database, but for one database you may have multiple instances. So for one database, if you have only one instance, you call it as single or standalone database. Or for one instance, if you have more than one, for one database, if you have multiple instances, then you call it as RAC, real application clusters. So that's the difference. And the data files, as we discussed, clusters, rack. So now we discuss the physical structures. First primarily is a data file where actually the real data where we load or whatever the data we insert or manipulate, the physically stored in the hard disk in form of data files. These files are recognized by Oracle database. We cannot read physically without having only read by the database, Oracle database. We can still see the files, but it will be in a form of the binary code. We cannot open that. And the second is control files. Control files will be having the information about the database, like how many data files we have, and what is the latest checkpoint number, and what is the latest data file header information, and what is the database name, and all these information will be there in the control files. And every time the checkpoint occurs, for every 3 seconds, the control file gets updated. So the control file will be having the latest information, and whenever you start the database, the control file will be read first, and it will identify what are all the data files it have. It will go and cross check, do we have all the files intact before starting the database, and if it finds all the data files, then it will start. Else, if any of the file is missing, it will invoke SMON to recover the database. And if file is physically missing or deleted by someone, the SMON is unable to recover, because SMON will only do an online recover when all the files are existing. Else, or manually DBA has to recover, and when DBA recovers, internally we will invoke the recover process. So we're restoring the files from the backup and doing the recovery, all the stuff. These we discuss in detail in the backup and recovery stuff. So that's the role of the control file. And the on and read log files we already discussed. It will have the redo data, whatever the transaction that happens in the database. And apart from this, we have a PGA. It is also again the memory. The PGA is nothing but the program global area. For each of the connection where the client connects to the database, you will have a server process and a memory assigned to that process, which is from the PGA. So altogether, a user process and a server process combinedly called as a session. And as a DBA, we will be monitoring how many sessions in the database and what are the status of the each session, what it is doing. For example, if a user complains stating that he filed a query but he is not seeing a response, so as a DBA, we'll log into the database and we'll identify what is his session and where it is waiting and what it is doing. If it is hung by any of the other issue, we will clear that session, ask the user to reinitiate the query, or we'll say if there is any performance issues where the query is hung, we will fix it. That's a DBA responsibility. Yeah, Amit, so far, any questions you have?
No, so far so good.
Yeah.
Everything is fine for now. Can you
So
hear
as
me?
I
Everything is
stated,
fine for now.
these yeah. So I'll stop for now. This is about the architecture introduction, how the Oracle is. Oracle is compromised
Okay.
with memory and the background processes. And if you're interested, you can discuss with Hussein, and you can commit to the class, and we can start.
Okay, I'll talk to Hussein then.
Yeah. Okay.
Okay. Okay. Nice. Nice talking to you.
Yeah. Thanks, Hussein. Thanks, Amit.
Yeah. Bye.
Bye.
How do I end this thing?
Hello? Hello?
Yeah, Hussein.
Yeah. Yeah, mate, tell me.
I'll give you a call. Okay.
Okay.
I'll give you a call.
Sure, please call.
All right. See ya.